Okay, let's go ahead and finish up some law of cosines work. Well, actually, this video, I'm actually going to use our law of sines in some of examples and our law of cosines in some of examples. It just depends on what's going on, okay? We just went through and looked at a lot of examples that used the law of cosines, and it used the, excuse me, sorry. I was making sure that you were seeing what I was writing. Make sure that we can use the law of cosines. We did a bunch of those examples. We can also go through and do some things by Heron's formula. We talked about finding area of any triangle when we don't know the height. Let's just look. We had a bunch of examples. I think I had like 9 examples in this section just that said try. Hopefully you've gone through and tried these, you've checked your answers, and you may need to run through and see a video solution to 1 or 2 of them. Feel free. I'm just going to work through them. So remember, you can fast forward, you can stop, you can pause, you can email me for questions and everything like that, okay? So let's look at the first problem. A triangular lot has sides of lengths 50 meters, 120 meters, and 150 meters. We want to find the largest angle of the lot to the nearest 10th. Now, remember with triangles, the smallest angle is going to be opposite the smallest side. The largest angle is going to be opposite the largest side. So the largest angle is going to be opposite of the 150 meters because that's the largest side. That's the angle that I'm looking for. Do I have an opposite side angle pair? No, I don't. I just know 3 sides. I don't know any angles at all, so I can't know an opposite angle side pair. So I'm going to need, I can't use law of sines. I'm going to need law of cosines for this problem. I'm trying to find an angle. So I'm going to use the form of this that says the cosine of C is equal to a squared plus b squared minus c squared over 2ab. Okay. Remember, the angle is opposite the side squared for the side that's opposite of that angle. So my C, excuse me, just a moment. Just a moment. Let me pause this. Sorry, had a little interruption there. We're looking for this angle. So the cosine of this angle is going to be equal to the side squared that's being subtracted is the side that's opposite the angle we're looking for. So that means the other 2 measurements are my A and B. The order really doesn't matter, okay? So I know I have cosine of C is equal to 50 squared plus 120 squared minus the side that's opposite, which is 150 squared, over 2 times the 50 and the 120. In order to find the angle, we're going to use inverse cosine. So C is equal to the inverse cosine of that big old fraction. Okay. And we have this. Now, when we're using law of sines to find an angle, we have to look at multiple cases. That's not true with law of cosines, okay? So inverse cosine of 50 squared plus 120 squared minus 150 squared. And make sure, again, it's easy when you're going through to think you typed everything and you didn't quite get there, okay? My fingers were going, my brain was going faster than my fingers. So let me retype it. 50 squared plus 120 squared minus 150 squared. That's whole numerator divided by that whole denominator. and I end up with 117.818, so on. The problem said to the nearest tenth of a degree. So next digit's a 1. I'm going to round that, keep it to an 8. So the largest angle is approximately 117.8 degrees. Okay, there's my answer. So, an application of the law of cosines. All right, let's go ahead and look at another example here. Here we're given a triangle. So try number 2. We have 2 sides. The angle in between those 2 sides is 140, and the opposite side of that 140-degree angle is x. So as we look at this, do we have an opposite side angle pair? No, we don't. So we can't use law of sines. So let's try law of cosines. We're wanting to solve for a side x. So I'm going to use the form that's the c squared equals a squared plus b squared minus 2ab cosine of c. Remember, the side involved in this side is the side you're trying to solve for. The angle is the angle that's opposite it. So I'm solving for this side x. That's going to be x squared is equal to the square of each of my other sides squared. So I have 25 squared plus 25 squared minus 2 times the product of each of those sides times the cosine of the angle that's opposite of x, that's 140 degrees. So x squared is equal to all of that, which means x is equal to the square root of that big old mess. Okay, so I'm going to grab my calculator and do it. I'm going to take the square root of 25 squared plus 25 squared minus 2 times 25 times 25 times the cosine of 140. And that gives me a 46.98, so on. So if I round to the 10th, next digit's an 8, I'm going to round that up. That's going to give me 47.0. So x is approximately 47.0. It's not degrees, be careful. It's not 47.0 degrees. It's the length of a side, okay? So if I knew inches or feet or centimeters, I would do that, but that's all I have for that one, okay? Let's go ahead and look at the third one. We're given a triangle. We're also looking for a side. We have an angle of 30 degrees. We have a side of 30. We have a side of x that we're dealing with, okay? And let's see what's going on here. Well, with this one, just a second. Let me pause for a second. Okay, sorry about that. I need to double check something. On number 3, we're given this triangle. We have sides of x, 24 and 30. We have an angle of 30 degrees. We're wanting to solve for side x. Now, as with all of these, do we have an opposite side angle pair? No, we don't. We don't know the angle opposite of 24. We don't know the angle opposite of 30. There's not an easy way to get them, so it's not going to be law of sines. Okay, so let's try law of cosines. We're wanting to solve for a side x. So we're going to use the form of the law of cosines, which is c squared equals the sum of the squares of the 2 other sides minus 2 times the 2 other sides times the cosine of the opposite angle of the side we're looking for. Notice x is opposite 30 degrees. So if we're solving for that side, I'm going to make that x squared. And my other sides are 24 and 30. So I'm going to square 24, add it to square the 30, my two sides, minus 2 times the product of those two sides, times the cosine of the angle that's opposite x, which is 30 degrees. So this means that x, our missing side, is the square root of this big old sum and difference. And I'm writing down, so I want to make sure that I keep it all correct there. So we have the square root of 24 squared plus 30 squared minus 2 times 24 times 30 times the cosine of 30. And so that's 15.13. It goes on. So x is approximately 15.1. I don't know the units involved in my sides. Again, make sure it's a side, it's not an angle, so don't put degrees or that sort of thing as you go through. Okay? So we've solved for x. Now in numbers 4 through 8, I had a list of them there for you to just try as you went through. And again, you might need law of sines, you might need law of cosines. We don't have a diagram going on, and that's okay. Let's look at what we do have as we look at this one. We want to solve this triangle. Whenever you see solve the triangle, what are you looking for? We know we have side A and side B and side C. So that means the things that are missing are angle A, angle B, and angle C. Those are our unknowns. Those are the things that we need to find. Do we have an opposite side and angle pair? No, because we have no angles. So we can't use law of sines. So again, just like we had done before, I'm going to go ahead and look at the law of cosines. Now, I'm going to do this to find an angle. And I have all three sides, so I can go for any angle I want to. I know I'm going to be solving for an angle. So I'm just going to start with the first angle I'm looking for, angle A. So I want to solve for angle A. Remember the form when you're looking for an angle is cosine of the angle is equal to a squared plus b squared minus c squared over 2ab. This is when your angle corresponds to the side square that's being subtracted. In this case, I'm looking for angle A. So I will go the cosine of angle A is equal to the sum of the square of my other two angles. Since I'm looking for A, that would be b squared plus c squared minus the part that's being subtracted corresponds to angle A. So that would be a squared over 2 times the other two. So this means we have cosine of A is equal to, my B was 12, my C was 44, A was 40, 2 times 12 times 44. So A is equal to the inverse cosine of that big old fraction. Again, you can simplify that fraction if you want to first, and then take the inverse cosine of your answer, or you can just type this whole big old mess in. But we have inverse cosine, the numerator, 12 squared plus 44 squared minus 40 squared. Okay. Divided by the product, 2 times 12 times 44. And I end up with a 62.96, so on. Let me double, that's my A, and let me double, oh yeah, 62.96, so on. So that's A. So if we round to the nearest tenth, that's going to round up. So A is approximately 63.0. A is an angle, it's in degrees. So A is approximately 63.0 degrees. okay? And I got that by law of sines. Now, here's the trick, and I didn't go through one of these before. Now, we have an opposite angle side pair because I know that angle A is 63.0 degrees, which means that my opposite side A is 40, so I have that. I can use law of sines. The sine of A is to 40 as, and now I can go for another angle. We'll do B. The sine of B is to side B, which is 12. So I have the sine of 63.0 degrees is to 40, as the sine of B is to 12. I cross multiply. That means the sine of B is equal to 12 times the sine of 63 degrees over 40. So B is the inverse sine of that fraction. Now, remember when we talked about inverse sine, when we use our law of sines, to get an angle, we're going to have two cases, okay? We're going to have two possible cases in those situations. So let's go ahead and look what's happening. I have inverse sine of 12 times sine of 63 divided by 40. And that gives me B is approximately 15.5 degrees. Okay, so I have two cases. B could be approximately 15.5 degrees, and B could be the supplement of that. 180 minus 15.5 would be 164.5 degrees. Okay, so I have my two cases there. All right. So what's that mean for angle C? Three angles add up to be 180. So 180 minus my angle A minus my angle B. So 180 minus 63 minus 15.5 is 101.5 degrees. Or angle C would be 180 minus 164.5 minus 63. Whoops, that's negative. Beats that. That can't happen. So my answer, A is approximately 63 degrees. B is approximately 15.5 degrees. And C is approximately 101.5 degrees. That's my solution. That's the only case that will work for this one, where A is 63 and B is 15.5, C is 101.5. So that's our solution for that guy, okay? Notice I used both law of cosines and law of sines there. Let's look at number 5. Okay. So number 5, solve the triangle given. Angle A is 30, angle B is 100, and angle C is 50. Here's a tip. If you have two angles, that means you're going to know all three angles. So if you know at least one side, you will have opposite angle side pairs. Notice we do have angle B is 100 and side B is 50. So we have 100 degrees and a side of 50 centimeters. We do have an opposite angle side pair. What do we need to solve this? We're missing angle C. We're missing side A and we're missing side C. Those are the things that we need to solve this guy. So we have this. We can use our law of sines because we know we have the ratio sine of 100 degrees is to its opposite side of 50. That's my A's. or sorry, that was my B's, rather. And I have angle A, so I could say the sine of 30 degrees is to side A. So those are dealing with our A's. We'll do our cross multiplying. A times the sine of 100 degrees is equal to 50 times the sine of 30 degrees. So I'll divide both sides by sine of 100. So A is equal to 50 times the sine of 30 degrees divided by the sine of 100 degrees. And that is 25.384, so on. That rounds to be approximately 25.4. That's a length of a side. Our sides were in centimeters. So A is approximately 25.4 centimeters. Okay, so there's part of our solution. So we have A. We need angle C and side C. Well, angle C should be pretty easy to get because we know two angles. We know three angles always add up to be 180. So that's going to be 180 degrees minus angle A minus angle B. So if you go 180 minus 30 minus 100, you're going to get 50 degrees. So angle C is 50 degrees, and it's exactly 50 degrees. We didn't estimate it. We didn't round it. That was an exact answer. How can we get side C? We can use law signs again. The sine of 100 degrees is to 50. That's dealing with B and B. Okay. So the sine of 100 degrees is to the side of 50 as the sine of, and I'm dealing with looking for side C. So the sine of 50 degrees, angle C, is to side C. And again, just like before, I cross multiply. Divide by sine of 100 degrees. So if you go 50 times the sine of 50 degrees divided by the sine of 100 degrees, we end up with 38.89, etc. So if we go to the 10th, that's going to round up to 38.9. And it's a side, so it's in centimeters for this one. So our answer for this, we solved the triangle. We found all the missing parts. Angle C is 50 degrees, side A is approximately 25.4 centimeters, and side C is approximately 38.9 centimeters. Okay, that one, we didn't have to use law of cosines at all. Number 6, again, we want to solve a triangle. We have angle C is 53 degrees, side A is 3, side B is 4.0. So what are we looking for in this problem? We have angle C, so we need angle A, and we need angle B. We have sides A and B, we need side C. Do we have any opposite side angle pairs? No. So it's not going to be the law of sines like it was the last one. And we'll go ahead and look at the law of cosines. Okay. Well, one thing that would be quick to do for this one is I know I have angle C and I don't know side C. So I could find side C by going C squared equals A squared plus B squared. So you take the side that you're looking for squared, take the square of each of the other two sides, add them together, subtract twice the product of the two other sides, times the cosine of the angle that's opposite the side you're looking for. So that would be cosine of C. So for this problem, C squared is equal to 3.0 squared, or just 3 squared, plus 4.0 squared, or 4 squared, minus 2 times 3.0 times 4.0 times the cosine of C, which is 53 degrees. So C is going to be the square root of that whole mess. Now, you might say, why are they giving us 3.0 and 4.0? It's so that you know around where they want to round the answer. Okay. So we're going to have the square root of that big old mess. So I have 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 53 degrees. And I get 3.249, so on, for that one. So to the 10th, C would be approximately 3.2. I don't know units for this one, so I'm just going to say C is approximately 3.2. So I have that part, okay? Once we have that, we now have an opposite angle side pair. We have angle C and side C. Once you do that, you can go to your law signs. We know that we can go sine of C is to C as, and we could do either the sine of B is to B or the sine of A is to side A. I know angle C is 53 degrees. So that sine of 53 degrees is to the side 3.2 as, well, let me do the B's. I don't know angle B, so I'm going to go the sine of B is to side B, which is 4.0. Cross multiply. Divide by the 3.2. Okay. So that means that B would be the inverse sine of that fraction. That's degrees. So we have inverse sine of 4.0 times the sine of 53 divided by 3.2. So that would be equal to 86.65, so on. So angle B is approximately 86.7 degrees. Let me make sure I typed it all in there. And you know what? I'm going to go ahead. What did I tell you all earlier? I said it's always nice if you don't round until the end of a problem, right? Let's not round until the end of the problem because that's going to throw it off. I'm dividing by this value right here. It's the 3.249, etc. 3.249, etc. If I don't round, I will get angle B is approximately 79.5 degrees. There's a big difference if you round and if you don't round. So do that just like we did before, where you say you have it in your calculator and you pull it in, and that'll be good because you do want to be as exact as possible. Now we can get angle A because you can go 180 degrees minus angle B minus angle C. So that'd be 180 degrees minus 79.5 degrees minus angle C was 53 degrees. So 180 minus 79.5 minus 53 gives you 47.5 degrees. Okay, so there's angle A. Again, it's rare that you have to use law of cosines more than once. We needed law of cosines to get one value. So in our answer, we can round, but we want to keep the unrounded version in our calculation as we go on. Okay, let's go ahead and look at number 7. Just a couple left. Okay, Solve triangle ABC given the angle B is 30 degrees, side A is 48, and side C is 38. We want to solve the triangle. So what's needed? We only know angle B. So we're going to need angle A, we're going to need angle C, and we know sides A and C, so we need side B. Do we have an opposite angle side pair? Nope. So this one's not going to be my law of sines. Okay. So I'm going to do law of cosines. And kind of like what we've had before, we do have angle B. I could get side B using law of cosines. Remember, the form of the law of cosines for a side is c squared equals a squared plus b squared minus 2ab cosine of c. The side involved here corresponds to the angle involved here. I'm looking for side B. So I'm going to have b squared equals the sum of the squares of my other two sides. So that would be a squared plus c squared minus twice my other two sides times the cosine of the angle opposite b, which is b. So that's the form that we have here. So b squared is equal to, a is 48. So I have 48 squared plus c is 38, 38 squared minus 2 times 48 times 38 times the cosine of b, which is 30 degrees. So to get b, I'm going to take the square root of that whole big old mess. And you can simplify the numbers a little bit in here. If you don't want to type out the whole thing, just don't round within. You can square 48, square 38, add them together, that sort of thing. But we have our answer. If we do this, just a second, I am having typos on my calculator here. Okay, minus 2 times 48 times 38 times cosine of 30. So I end up with 24.26, so on. So if I round to the 10th, that is approximately 24.3. Now, do I know units? I don't know units. So B is approximately 24.3 units, whatever they are, inches, feet, whatever they are. Now, we need our angles. We do have an opposite angle side now. Again, I'm going to be as exact as possible in the problem, but I can go to my law of sines. I know that angle B is 30 degrees, and I know that side B is that 24.2639. It goes on forever. I have it in my calculator, and we'll leave it there. So I can use law of sines where I go sine B is to B. So the sine of 30 degrees is to that 24.263, so on. As I need to go after one of my angles. It doesn't matter which. I'm going to go ahead and go after sine of A first. So I'll say sine of A is the side A, which was 48. I'm going to cross multiply. So I have 48 times the sine of 30 degrees equals that 24.26, etc., sine of A. That means sine of A is equal to 48 times the sine of 30 degrees over that big old number. So A is going to be the inverse sine of that fraction. So I'll go through and I'll do inverse sine of the fraction, 48 times sine of 30 divided by that 24.2639. It goes on. I'm pulling in the exact answer from my calculator. And that's 81.541, etc. Now, I used the law of sines to find an angle. That means we have two cases that could happen. So case one would be that angle A is approximately 81.5 degrees. Case 2 would be that angle A is the supplement of that. 180 minus the 81.5 is the 98.5 degrees. We already know angle B. Remember, we were given angle B was 30 degrees. So we have A and B in both cases. What's the one thing we have left at C? So angle C is going to be 180 degrees minus angle B and angle A. So I have 180 minus 30 minus 81.5. So that would be a 68.5 degrees in this case. In the second case, I'd go the 180 degrees minus the 98.5 minus the 30. And I get 51.5. All of those are valid answers. They're all positive. So our answers for this one, we have two. We know angle A is approximately 81.5 degrees. Angle C is approximately 68.5 degrees. And our side B was approximately 24.3. That's one answer. And we have another answer where angle A is approximately 98.5 degrees. Angle C is approximately 51.5 degrees, and side B is approximately 24.3. We have two possible triangles that will work for our given information. Okay, so that one had a lot to it. We had to use law of cosines to get a missing side so that we could get an opposite angle side pair. Then we had to use law of sines to get the other two angles. Okay, let's look at number 8. In number 8, solve for triangle ABC. Given the angle B is 40 degrees, side B is 125, and side C is 162. What is it that we need? Well, we have angle B, but we don't have angle A. We don't have angle C. We have sides B and C, but we don't have side A. So those are the things we need. Do we have an opposite angle side pair? Yes. We have angle B and side B. So we can use law of sines here. Using the ratio, the sine of B is to B. So the sine of 40 degrees is to the side of 125 as, let me go ahead and go after angle A first. That can't. I don't know side A. I can't go after A first. But I do know side C. So I can go after angle C. The sine of C is to 162. So again, you can cross multiply. So we have 125 times the sine of C equals 162 times the sine of 40 degrees. Divide by 125 on both sides. So that means you have the sine of C is equal to 162 times the sine of 40 degrees over 125. Okay. So inverse C is equal to the inverse sine of that fraction. Now, we are finding an angle with the law of sines. That's the one case, that's the one situation where we're going to have to look at two cases. Let me go ahead, do inverse sine of 162 times sine of 40 divided by 125. And you're going to end up with C is approximately 56.4 degrees. It's 56.413. C is an angle. So that's approximately 56.4 degrees. So one of my cases is that angle C is approximately 56.4. That means that my second case, angle C would be 180 minus 56.4. That's 123.6 degrees. That would be that case there. Okay. So what's that mean about, let's see, that's angle C. We need angle A. Angle A we can get by going 180 degrees minus angle C, minus angle B, which we know. So angle A would be approximately 83.6. Let's see, 56.4. 180 minus 56.4 minus 40. That's an 83.6 degrees. This case, angle A would be 180 minus the 123.6 degrees minus angle B, which is 40. That is 16.4 degrees. So we have angle C and angle B for both of these cases, okay? I still don't have side A. I've just used law signs for this. I still need side A. So let's go through and we can get side A because we know sine of B is to B as the sine of A is to A. We would have to do that for each of these though because A is different in each case, right? So we'd have sine of 40 degrees is to side B as the sine of 83.6 degrees is to side A, cross multiply. Okay. Divide both sides by the sine of 40. So in this case, if we went 125 sine of 83.6 divided by sine of 40, we get 193. It's 193.25 so on. So that would be approximately 193.3. So in this case, A would be 193.3. You'd have to do the same thing over here. The sine of 40 degrees is to 125 as the sine of A is to side A, or sorry, yeah, side A. So we cross multiply. Divide by sine of 40 degrees. So do that fraction. 125 sine of 16.4 divided by the sine of 40. So here we get 54.90, etc. So A is approximately a 54.9. Okay, so we have two solutions. In one solution, angle C is 56.4 degrees. A is 83.6 degrees. And side A is 193.3. The other one, C is 123.6 degrees. Angle A is 16.4 degrees. And side A is 54.9 units. So two solutions. We use the law of sines like crazy with that guy. Okay? Almost done. One more problem. All right. Look at this one. Find the area of a triangle whose lengths are 9 inches, 12 inches, and 15 inches. A Heron's formula problem. We don't have the height. We just know the three sides of the triangle. So remember the two things that we're going to need. We're going to need the semi-perimeter. So the semi-perimeter S is half of the sum of those sides, 9 plus 12 plus 15. So if you take half of 9 plus 12 plus 15, you end up with a semi-perimeter S of 18. Heron's formula says you find the area of a triangle by taking the square root of s times, you're going to have three more factors. Each factor is the semiperimeter s minus the side. So s minus side A, s minus side B, s minus side C. So for this problem, s is 18. So we have 18 minus A. A for this problem was 9. 18 minus B. B for this problem was 12. And 18 minus C. C for this problem was 15. So we have the square root of 18 times 18 minus 9, or 9, times 18 minus 12, or 6, times 18 minus 15, or 3, and we get 54. So the area of the triangle is approximately 54. Remember, area is always in square units. We're given inches. So the area of the triangle is approximately 54 square inches in size. So we can use Heron's formula to get area of triangles. So those were just a bunch of examples using law of sines, law of cosines, Heron's formula. Some came from our section on law of sines, some came from our section on law of cosines. Try your homework from those two sections. Talk to me, talk to a tutor. Let me know if you're having some questions from that, okay? That's the last part for that particular chapter, and we have a couple of other things we're going to look at. We're getting close to the end of our trig class, okay? Yell if you need me.